Metallic materials are widely used in many areas of everyday life. To produce the best quality of product material, metallography is the common method to preparing specimens for microscopic examination. Grinding and polishing as the key process of metallographic to determine if the material has been processed correctly or not. The specimen grinder is a machine that is used to grind and polish specimens for materials studies. The specimen surface is ground and polished until the surface is mirror-like so that the microstructural can be observed under the microscope. Typically, the process of grinding and polishing the specimens will take a long time and require the user to hold and apply pressure to the specimens calmly and evenly until the abrasive paper compensating the tendency for the sulfur to tilt. User also need to make sure not to grind fingertip accidentally. This process need to be done statically whether in standing or sitting posture for the whole process. The problem that people are having in Faculty of Manufacturing, Universiti Teknikal Malaysia Melaka is specimen grinder machine in the Engineering Materials Laboratory of Faculty of Manufacturing Engineering is limited since it is very expensive and some are under repair, compared to the number of students who use them. The number of specimen grinder in the laboratory cannot accommodate the number of users. This situation affects the efficiency of the learning process, especially during specimen preparation. This causes a bottleneck situation where the students are stuck taking turn to use the small number of specimen grinder while the microscope station for microstructural observation are unoccupied. The existing specimen grinder is not portable, it is fixed on the work table and its height is not adjustable. The machine is very heavy and difficult to be moved around. This makes the machine relocating process extremely difficult and require extra worker to lift and move the existing specimen grinder. Besides, current specimen grinder is not designed to match the various height of students and other users, thus causing ergonomics issues such as awkward posture, for example like back and neck pain during and after they use the machine. This issue is very critical since the user will use the machine for a long period of time for every session. The portable specimen grinder and polisher will consist of three main subsystems which will support the full functionality of the machine. The first subsystem is the height adjustment system. The components that related to height adjustment operation are the upper deck, lower deck, and mechanical jack. The design used to allow for height adjustment is by having dual deck design where the upper deck's legs will be tucked into the lower deck's hollow legs. This allow the legs from upper deck to slide into the lower deck, thus making it lower, and when it is slide outwards, it will increase the height of the machine. The mechanical jack is connected to both upper deck and lower deck. The second subsystem is the power transferring system. For the portable specimen grinder and polisher, pulley system is chosen as the power transferring system. This is because pulley system allows for a more flexible power ratio configuration and it can work for a long period of time without the need of cooling or lubrication. The main driver of the system is a high-torque electrical motor which transfer the power to the pinion then transfer power to the pulley through the multi-V belt, the shaft that is connected to the pulley and rotating plate then transfer the power from pulley to the rotating plate to spin the rotating plate. The third subsystem in the portable specimen grinder and polisher is the portability system. A set of 4 wheels is attached to the lower deck of the machine to reduce the friction when moving the machine from a location to another location. The wheels are also 360 degrees rotatable to allow for a better maneuverability. This machine also have emergency stop button for safety purposes. There are 20 components in total in constructing the portable specimen grinder and polisher prototype. Assembly process of the portable specimen grinder. Firstly, fabricate the upper deck. Cut each part accordingly to the required dimensions. Make holes and attach each parts by using MIG welding machine as shown in the video. Secondly, with the same technique, fabricate the lower deck. Cut each part based on predefined dimensions. Then weld each parts using the MIG welding machine. Step 3, attach the wheel to the leg of the lower deck. Mark each position of the hole at each leg. Drill each of the marked position with diameter of 8 mm. Now you can install the wheel and fasten using bolt and nut. Repeat the same process for another 3 wheels using the same step. Step 4, attach mechanical jack. Place the mechanical jack at the center of the lower deck. Weld along the side of its base. Attach the upper deck to lower deck by insert the leg into the hole. Now, weld the top of the mechanical jack to upper deck. Step 5, attach electrical motor. Place the electrical motor into the hole at the inner plate. Fasten the electrical motor to the plate by using bolt and nut. Step 6, place the pinion at the shaft of the motor and tie it using screwdriver at the side of the pinion. Step 7, mount the shaft to the rotating plate by slot in the shaft pin to the rotating plate. Then place it through the top hole at the upper deck. Step 8, insert bearing into the shaft and attach pulley at the bottom of the shaft. The position height for pinion and pulley must be parallel. Step 9, install the idle pulley bracket to the inner plate by using bolt and nut. Attach bearing at the center top of the idle pulley bracket with bolt, washer, and nut. Step 10, install multi-V belt around pinion and pulley as shown in the video. Step 11, install the control panel with the wiring system at the inner plate area. Step 12, weld the container holder to the inner plate. Then, attach the pipe and water drain container. Step 13, place the water bottle holder next to the rotating plate at the top plate. Assembly the bottle holder by using rivet process. Step 14, drill 4 holes at the top plate to install the specimen holder. Fasten it with bolt and nut. Step 15, weld handlebar to the left and right of the machine. Step 16, the final step is place the cover on top of the top plate and weld it. We are done. How to use this portable specimen grinder. Step 1, lock all 4 wheels. Step 2, load the sandpaper if you want to grind the specimen. Otherwise, load the polishing pad to polish the specimen. Step 3, place the ring on the rotating plate. Step 4, squeeze some water to the plate. Step 5, switch on the machine. Make sure the plate are rotating. Step 6, attach the specimen to the holder. Now you can start grinding or polishing. Comparison between existing and portable specimen grinder and polisher. The new design of product is portable compared to the old design is fixed on the work table. For the old design the height is fixed, and the new product can make it adjustable to prevent the ergonomic issues. The new design of product is lightweight co-mapper to the old one. And finally, the new design can be automated operation without handling the specimen manually. Sustainable manufacturing for this project can be defined as a method for manufacturing that minimizes waste and reduces the environmental impact. The ultimate aim of sustainable manufacturing is to gain an overview of the entire product cycle and to maximize the life cycle of production processes. The way that can implement to save our manufacturing costs is by reduce the fabrication costs. This can be done by tweaking the design of our products and utilizing all the resources that we have. By using reuse component are more efficient, we can save money and help protect the environment. For this product, recycle and reuse the part or component from the washing machine which is no longer used. First component is motor to convert electrical energy to mechanical rotation energy to move the rotational plate. This can reduce the fabrication cost for this product. To buy a new motor, cost is too expensive. Low costs of fabrication able to supply more of a product at a given price than those with higher costs of fabrication. Belting from the washing machine which is to transfer the power to the pulley to rotate the rotating plate for grinding and polishing process. Last is pulley, which received rotational energy from pinion while increased torque with high pulley ratio. All the three components are from washing machine, which is no longer used. A lot of money can be saved and provide great environment benefits when reuse and recycle component from washing machine. Thermal stress analysis is performed on the parts of the machine with heat and thermal stresses. This analysis is to observe the heat dissipation and distribution performance. The analysis performed by SolidWorks simulation to create thermal mapping of components. The specimen grinder and polisher is used widely in the educational institutes and industries. Educational institutes such as universities, colleges, polytechnics, and schools use specimen grinder and polisher for teaching and learning process. The development of the ergonomic specimen grinder and polisher will be able to provide a more ergonomic and comfortable working posture to the students and researchers in the field of material engineering. We truly hope that this will greatly reduce the risks to musculoskeletal disorders that will be potentially causes injuries and disability in the long run. This product will also be beneficial to the industries such as Serum will be able to make use of the ergonomic specimen grinder and polisher in their testing laboratory. The risks of workplace injuries due to the awkward posture during specimen grinding and polishing when testing products can be decreased significantly. Moreover, industries that own research and development (R&D) department can incorporate the ergonomic specimen grinder and polisher in their laboratory to improve the workplace ergonomics. Last but not least, this product was recognized as a first runner-up in integrated design project competition conducted by the Faculty of Manufacturing Engineering, Universiti Teknikal Malaysia Melaka on 6 January 2021.